Yeah, good evening, everyone. I hope you had a great, beautiful day. Okay, I hope I'm audible to everyone in the class. Please, can you indicate if you can hear me, please? Okay, that's so great. Okay, that's good to hear. All right, hope you're enjoying yourself. You have a few days. Your countdown is here, so guys, hope you're not feeling the pressure too much. All right, you guys have been doing really great, and we have come this far because of your cooperation, and we still have a few hurdles to jump. And in today's class, we want to be looking at a different aspect under random variables, but in a different light. So in this class, we'll be talking about probability distribution functions. All right. So we want to delve into probability distribution function. All right. Let's talk a little bit on this. It's quite very interesting, quite very uh it's so interesting, it's so direct, so simple, very, very simple. Can anybody type simple in the comment section? Just type simple. All right, type simple. Type simple. This is so simple. So brace up, this is so simple. Very simple. Let me get 5 people typing simple. 5. Okay, good, good. Somebody, it's all simple. Yeah, thank you. Simple. It's so simple. You should relax yourself. There's nothing hard in this at all. It's so simple. All right. So we're going to be starting from this. Now, guys, when you talk about probability distribution function, you can see the word distribution here. So obviously, you know that what I want to talk about in this class will be majoring on this. First of all, let me see if you guys can follow through on me. Uh, if I'm talking about distribution function, what do you think I'm addressing in this? Is it discrete or continuous? If I mention distribution, well, if I mention distribution, you know I'm talking about discrete because I told you guys that when we say distribution, the last time, who is this person in the chat? Okay, so distribution is for discrete. When you say density, what topic is that the covenant is referring to? What topic did I say was simple? So when we say density, we're talking about continuous. All right. So you can see I'm saying probability distribution function. So you know, obviously, I will be talking more on discrete, discrete, not continuous. So under the probability distribution function, we'll be looking at four different um, distributions. We're talking about the first, which will be the Bernoulli. The second will be the binomial. The next will be Poisson. And the last in this coverage will be geometric. We have other ones, obviously, but this is the one we'll be settling for in these classes for now. Right now, when we say probability density function. When you hear probability density function, of course, you know you're dealing with continuous distributions in that regard. Now, we'll be spending more of our time on normal distribution. All right. This is where we're going to spend more of our time on. We're spending more time on normal distribution when we get into density functions. Now, we're starting from distribution functions. That's discrete random variables. So you know that all of these 4 distributions will all be modeled according to the discrete settings. And when you hear the word discrete, I'm sure everybody in this class now should understand the use of the word discrete. Represents a countable data set. So when you're talking about discrete, if we say x is 0 to 10, of course, you understand that in this case now, x will take countable values, integer values, 0, 1, 2, 3, 4, 5, 7, 8, 9, 10. That will be the value you'll be taking as your x because they are all discrete. But when you talk about continuous, you know, this data set occur in bands. So if you say x, you say 0, x, 3 values, you're talking about a boundary. So that's the difference between discrete and continuous, the most obvious difference. All right. Now we are dealing with Bernoulli binomial Poisson geometry. All these follow discrete random variables, whereas that of density function, continuous function, will be talking about normal distribution. That will be in some weeks ahead of this class. All right. Now we're dealing with Bernoulli in this class. Let's start with Bernoulli because Bernoulli is the first and the most simplest of them all. Bernoulli is so simple that you guys you could decide not to even listen and still understand it. That's how simple it is. All right. Now, let me know. Okay, guys, can you still hear me? Are you still here? Can you still hear me? Please, can you indicate if you can hear me if I'm audible to everyone? Is somebody hearing me there? Okay. So now, guys, pay attention. We want to start from this very first one, and that's Bernoulli. So simple. I told you it's too simple. And every other one are just as simple. But let's start from Bernoulli. What's Bernoulli distribution? Now, let's start from the definition of Bernoulli distribution. Now, this is a discrete probability distribution. Of course, you know that already because I said that some minutes ago. It's a discrete probability distribution. Now, which takes two values. Now, before I go on, let me tell you one thing you must hold on to when you are preparing for an exam and you are having a topic like this to prepare for. You will come across questions where they will not tell you what distribution is happening here. And that's why you need to pay attention to the features of each of these distribution. You must understand what each of these distribution entails, each of them. You must understand what they are about because the examiner will not tell you and say probably, oh, this thing follows a binomial distribution. Oh, this question follows a Poisson distribution. They will not tell you that in some cases. If you're lucky, they tell you. In some cases, they will not tell you. They'll just say, let me read an example for you now. Approximately 1 in 200 American adults are lawyers. 1 American adult is randomly selected. What is the distribution of the number of lawyers? Let me read that again. Approximately 1 in 200 American adults are lawyers. 1 American adult is randomly selected. What is the distribution of the number of lawyers? Now, when you see questions like this, you can see that nobody is telling you, oh, this follows a geometry, this follows a Poisson, this follows a binomial, this follows a Bernoulli. No, nobody will tell you that. You must understand what each of distribution entails, what their features are. And that's what's going to inform you on. When you look at the question, then you'll be able to say, oh, I see this here, I see this here. Oh, this is going to be a Bernoulli distribution. Oh, this is going to be a binomial. So you must really be very curious to understand each of their features, which I'll be saying in a few minutes. Now, let's get into binomial and let's talk about the features of binomial. How do you recognize a Bernoulli distribution? Now, before I go on, I want you to understand that these two distributions, they are very much alike, and I will tell you the difference. Bernoulli and binomial, there's just one thing that differentiates them. They are like the same thing, only one thing that differentiates. I'll be highlighting that thing to you now. All right. Now, Bernoulli distribution is like the bedrock. It's like the foundation. It's like the most basic. And why is it the most basic? It's the most basic because there is only one trial involved. So let's talk about Bernoulli now. Bernoulli. What's the feature of Bernoulli? Number one, we say it's a discrete. It's discrete. You already know that already. Now, number two is that only one trial is involved. Only one trial. Now, don't forget, we're talking about probability distribution function. So you guys are already, that's why I told you guys when we started probability, I told you that it's very important you understand it well, because you'll be seeing its usage in several other topics like this topic now. Now we say probability, and so you understand. So what do I mean by trial? Because I don't want anybody here to be getting it, and I don't want you to get any of these features confused. What's the meaning of trial? What does trial mean? Now, when we're talking about probability as a whole, you understand that probability has to do with experiment. And then when we say experiment, we're talking about a particular situation. For instance, let's say the most common one is the one that has to do with a coin. So if you want to do an experiment and you say, okay, guys, let's toss a coin. I'm sure of getting a head. Somebody say, oh, if you get a head, I'm going to give you 10 naira. If you get a tail, I'm going to give you 5 naira. So nobody knows what will happen. Number one, if it's a random experiment, we say random variable. If it's a random experiment, there must never be a predefined answer. All right? We must never have a predefined answer that we're sure that it's going to be a head. Once there's already predefined outcome, it's no longer a random experiment. All right. So now you give somebody the coin. So you toss this coin. When you toss that coin up, that's one trial. All right. Now, if you tell the person to toss the coin up 5 times, that's 5 trials. So it's possible for you to say, okay, guys, I'm going to give you the permission to toss this coin 10 times. If you can have a head 7 times, you're going to get 100 naira. If you have you understand all I'm trying to bring out from that. Now, what I mean by that is you have made the person, or you are permitting the people or whoever is involved to have 10 trials. Now, but let's say somebody says, come, it's just once I'm going to give you the permission of just toss this coin up once. Once you toss it up, if you don't have a head, that's all. You only have one trial. So you understand the meaning of the word trial there. Now let me give you a different scenario, because the one of tossing a coin may probably be a bit very common. Now, another scenario is, let's say you guys are in the class and I give you guys, let's say you are 50 in the class, and I say all of you pick a number with 1, 2, 3, 4, 5 up to 50. Now, if I give someone probably an assignment, I say, I want you to pick any of this number, and let's see if the number you pick is going to be a guy or a girl. So we're not sure. It's a random experiment. So I give you the basket filled with the numbers. So the person puts his hand inside and picks number 14. Then he comes into the class and says, who is number 14? And then the girl raises up her hand and say, I'm number 14. So obviously the trial was a girl. Now, if you look at what I'm saying here, if I say pick 5 people, pick 5 numbers, it picks the first person, it picks the first number, it gets 14. That was a girl. It picks the second number, it picks the third number, it picks the fourth number, it picks the 5th number out of 50. Now, that means he had 5 trials. So don't always get trials in terms of tossing a coin up or tossing a dice up. No, it may be you selecting a person. So once they say you are selecting one person, then you know that's just one trial. If they say you are selecting two persons, that's two trial. If you are to select 5 balls from a basket, that's 5 trials, because you would have to put your hand inside 5 times out into the basket. But if they tell you just pick one ball, once you see it's just one selection you have to make, that is obviously just one trial. So now let's come back to Bernoulli. Under Bernoulli, you only have one trial. So once you see any question that talks about you just doing one selection, one trial, guys, that's a Bernoulli distribution. But that's not the only feature. There are still one more feature I need to talk about. In that one trial, there is only 2 possible outcomes. Only 2 outcomes. If there are 3 outcomes, it's not a Bernoulli. If there are 4 outcomes, it's not a Bernoulli. There must be just 2 outcomes. Now, what are those 2 outcomes? We always call those 2 outcomes, divide those 2 outcomes. Of course, 2 outcomes will be divided into, we say success and we say failure. All right? These are outcomes that you see in a Bernoulli distribution. So let me start from scratch again. Bernoulli distribution is a discrete probability distribution. Number 1, it has only one trial. Only one trial. Now, in that one trial, there must just be 2 possible outcomes, which will be success or failure. Now, I need to get you guys to understand the use of this word success or failure. Let's use all the experiments we have used, the examples I've given. If you are tossing a coin up, it's possible that, let's say you are having an experiment, and it's possible for you to say having a tail may be a success. So don't take head as success and tail as failure. No, don't take it that way. Depending on whatever the experiment was tailored towards. Let's say, for instance, getting a tail was going to be what you will need to make an advancement. That means getting a tail, if you toss a coin up, will be seen as success in that case. But it's possible also that getting a head may be what will be seen as success. So you see, when you toss a coin up, there are 2 possible outcomes. It's either you get a head or get a tail. Now, if you're getting a head, you say that's success. If you're getting a tail, you say that's failure. All right, good. Let's use another example. If you are picking a student in a class, if you are asked to pick a boy, if you pick a boy, when you put your hand inside that basket, for instance, if it's a boy, then you say you had success. If you say if it was a girl, then you say you had failure. But if you were asked to pick a girl, picking a girl would have been, if you pick the girl, it would be seen as success. If you pick a boy, in that case, you will see it as failure. Now, look at all this scenario. There's something I'm now going to tell you, because I wanted to say it that way so that you guys will understand it very well. But I now want to take it to a different level of this success and failure. Let's talk about a dice. If you were told, how many possible outcomes do you say a dice has? Many people want to say a dice has 6 possible outcomes, but that's not true. This is why. If I say toss a die, I want you to get, let's say, what's the number you have to get for you to start in a Ludo game? Is it 6, right? You want a 6, am I right? If you're playing Ludo game, for you to start the whole thing, you have to throw a 6, right? Now, if throwing a 6 is seen as success, every other thing apart from 6, not 6. Now, it may be 4, it may be 1, it may be 3, it may be 2. Any other thing apart from 6 will be seen as failure. So a dice is also going to be seen as a Bernoulli distribution. So don't get it wrong that the meaning of 2 outcomes mean that they must just be 2, like head, tail. No, that's not what that means. It could be in a scenario where 6 is seen as success. Every other thing that is not 6 is seen as failure. All right. Now, some other examples would be for you to get true or false. All right. Boy or girl, dead or alive, cured or not cured. All right. As I said already, a 6 or not 6. Those are examples of two possible outcomes. Now, if you look at exactly what I've said here in summary, I've told you guys now that when you have a question, any word problem that you see, number one, once you see that that word problem is dealing with just one trial, start becoming conscious that that looks like a Bernoulli distribution. But you need to go further to investigate that. Does this one trial have two possible outcomes in any of the cases I've mentioned? If that's the case, then that's a Bernoulli distribution. So let's see some quick examples. Before I go on to examples, let me talk about something which is very vital, very, very vital. Because we said it's a discrete probability distribution, you need to understand that there must be a PMF. All right, a PMF. That means a function that will be used to represent this distribution. Every one of them have this PMF. Bernoulli Binomial Poisson, they all have their respective PMFs. So what's the PMF for Bernoulli distribution? This is how we write it. I'm sure you guys already know how we write PMFs already. We write it as P of x equals to x. That's, of course, x being a random variable and x being the outcomes of the random variable. All right. So you are used to this. Some other people could write it as f of x, but it's always good to write it this way, especially when dealing with discrete. All right. Now, what is the PMF of a Bernoulli distribution? Now, I don't want to jump into the PMF without saying this. When we mention these two possible outcomes, success or failure, guys, this is a very vital part. The next thing I want to say is too vital, very, very vital. Look at it, success or failure. Under Bernoulli, the probability of success is always denoted as P. Probability of success under Bernoulli is seen as small letter p. Now, probability of failure, I'm sure you guys know that the total probability of anything is always 1. So probability of failure will be seen as 1 minus p, which we always represent it also as q. So that means when you're dealing with Bernoulli distribution, if you have to talk about the probability of success, always remember that it will denote it with small letter p. Probability of failure will denote it with small letter q, but q can also be seen as 1 minus p because p plus q must give you 1. You'll know that already, that the total probability of anything, any experiment, the total probabilities that exist must all equal to 1. So probability of success is p, probability of failure is q, and don't forget that p plus q must be equals to 1. Good. Now that you are following, let's now go on now to talk about the PMF, because it's important you have the probabilities for you to be able to talk about the PMFs. The PMF, this is how you get the PMF. What did I wrote something here. I said random variable x equals to small letter x. Now the question is, what is small letter x? What is small letter x? Because I told you guys already that the key to understanding this thing is to understand every detail. X represents the number of success in the trial. Now, I'm saying it this way because I want you guys to, I want you guys to be able to relate this to every other thing. Now, what does this mean? If I write p x equals to 0, no success, that means I'm saying there was a failure. And if x equals to 1, that means I'm saying there was success, one success. Just calm your mind. This is the first story. Obviously, some things are just coming newly. Now, to build the PMF, because I want you guys to understand how to build the PMF without having to cram it. The best way to understand the PMF is to see it like this. This is how I used to teach students generally. Success, probability of success, raised to the power of number of success. Failure, raised to the power of number of failure. It's easy to understand it this way rather than cramming the formula. Now, how do I write this mathematically? I'll write P raised to the power of X. Then I could write Q, but I'll be writing it as anyhow you want to write this. 1 minus P, which is still Q, raised to the power 1 minus X. So this is the PMF for Bernoulli. I'm going to explain to you every aspect of it. You don't need to feel confused at all. Now, the reason why you see that I wrote the trial here, and I didn't say I represent the number of success. Actually, in this case, there's only one possibility of getting success because you only have one trial. So you cannot have more than one success. That's the reason why you see I did not write in trials. Now, when we get into binomial, all these things will still move very similarly. I told you they are very similar. But the difference would be that binomial is not one trial. By say it already. The difference between Bernoulli and binomial is that the difference is just that binomial is n trial, is more than one trial, while this one is just one trial. That's the difference between Bernoulli and binomial. So everything you are listening to right here for Bernoulli, we're going to apply the same thing to binomial. The difference will only be that instead of one trial, we'll be having two trial. Sorry, 2, 3 to n trial. Now, look at what I wrote here. We have one trial. That's the reason why we're having 1 year. I said number of failure. If X represents the number of success, you obviously understand that 1 minus X should represent the number of failure. Let me say that again. If X represents number of success, 1 minus X will represent number of failure because we have only one trial. So if, let's say for instance, you toss a coin. If you toss a coin up, you only have, and let's say getting a head is seen as success. If you got a head, that means your number of success is 1, and your number of failure will automatically be 0. So if X is 1, that means you had success. Then that means you will not have any failure. And if X was 0, that means if there was no success, then that means your number of failure will be 1. So you can see how this works out mathematically. We have 1 year representing, this 1 year represents the number of trials. For binomial, it will be 1, it will be n. All right, for binomial, it will be n. The reason why it's going to be n is because if you add, let's say, let me try to just run into binomial just for the sake of explaining this. If you had 5 trials and you had 2 successes, that means obviously that in that case, X will be 2, your number of failure will be 5. That's why we're not going to be having 1 in binomial. We're going to be having n. Whatever the number of trials is, that'll be 5 minus 2. That means if you have 2 success, that means you'll be having 3 failure. That's just how this thing works. So, but because in this case, we're not dealing with just we're not dealing with multiple trials. We're dealing with just 1 trial. That's why the PMF is written this way, where we have 1, the number of trial in Bernoulli is just 1, minus X. X here is representing the number of success in the trial. All right. So if X is 1, that means we had 1 success. Then your number of failure will be 0. That'll be 1 minus 1, 0. If X was 0, then your number of failure will be 1 minus 0. That means you had 1 failure. It's so simple. So once you have these things settled, you don't go wrong. Now, to go back to the explanation of the PMF, we say the probability of success, which was P. This is just a very good way of remembering it. Some people may not even explain it to you this way. They'll just write the formula and say this is it. And then many of you will have to go on to be cramming this. But I'm trying to prevent that. That's why I'm just saying probability of success over number of success, probability of failure over number of failure. So see this way as P raised to power X, 1 minus P. Some people may write Q here, 1 minus X. All right. So this is the PMF of Bernoulli. We're going to talk about the PMF of other ones. Now let's go into some natural examples so that you guys will understand this much better. All right. So guys, let me get feedbacks from you. Are you rocking this? Do you have any question to ask? Don't forget Bernoulli discrete probability distribution. The meaning of discrete means in this case, our X values are going to be integers. We're never going to be having boundaries or everything. We're going to be having one. If it's one success, two success, that's what we're going to be dealing with here. 1, 2, 3, 4. You're going to be countable. All right. One trial for Bernoulli, only one trial. If you are tossing a coin, you are tossing that coin only once. If you are tossing a die, you are tossing that die only once. Once you are doing that in any experiment, just understand that that's modeling a Bernoulli distribution. Now, in that one trial, you must have two outcomes, success or failure. And success could mean something, and failure will mean not that thing. It's just very simple to understand. And then you have to also remember that we deal with the probability of success representing it as P, and the probability of failure represented as Q, which will obviously be 1 minus P. Of course, P plus Q must be equals to 1. And then we went on to talk about the PMF of this distribution as P raised to power X, then 1 minus P, which is Q raised to power 1 minus X. All right. Now, I want to add two things so that you guys are sound in this. In every of the distribution, we're going to be talking about the mean and variance. All right, because every of the distribution have mean and variances. So the mean of a Bernoulli distribution is the probability of success, P. Note that. And the variance of the Bernoulli distribution is the multiplication of the probability of success times the probability of failure. Very simple, right? This is so simple for you to remember. The mean of a Bernoulli is P, the variance is P times Q. Now, I told you guys, this Bernoulli and this binomial, they are the same thing with just one exception, one trial. So I can tell you already, even though we're going to get to that very soon, that the mean of a binomial, the difference is just that we'll be having it as NP. And the variance of a binomial will be NPQ, binomial. The N there is because we're having more than one trial. That N there represents the number of trials. So you guys already know the mean and variance of both Bernoulli and binomial. It's that simple. All right. So the mean of a Bernoulli is P, the variance is P times Q. The mean of binomial is NP, the variance is NPQ. That's just adding the number of trials. All right. So guys, let's now get into examples. Are you guys ready? I'm not seeing your chat. What's your feedback? Okay. You guys are enjoying yourself, I guess. You're rocking Bernoulli. So let's see how we move from here. We have this question, and I want you to please pay attention to the I want you guys to pay attention to the atmosphere around this question. So this is the question you are writing down, of course. Toss a fair coin once. Toss a fair coin once. What is the distribution You know that when I write DSN, I mean distribution, right? What's the distribution of the number of heads? Toss a fair coin once. Toss a fair coin once. What is the distribution of the number of heads? Now, I want you to understand that don't think you're going to say anything around maybe you have to this is a Bernoulli or anything. Nobody's going to tell you that. You're just going to say a question like this, toss a fair coin once. Let me ask you guys, when you say a question like toss a fair coin once, what kind of distribution comes to your mind immediately? Guys, toss a fair coin once. What's the division of the number of heads? Toss a fair coin once. Thank you. What distribution are we talking about when you say toss a fair coin once? Of course, they have specified already that this is one trial. Toss it once. They were restrictive. They don't want this toss twice. They don't want this toss 3 times. Toss a fair coin once. Once. That is one trial. Now, the question said, what's the distribution of the number of heads? Guys, when you hear what's the distribution of the number of heads, let me teach you how to answer questions like that. The meaning of this is that they want you to go on to bring out the PMF based on what you have. That's the meaning of this word. What is the distribution? Now, you know generally that I told you already that the PMF of a Bernoulli, you already know it already. I said number of probability of failure, probability of success over number of success multiplied by probability of failure or raised to the power of, probability of success raised to the power of number of success, probability of failure raised to the power of number of failure, which is this. Now, when they say what's the distribution, when they say what's the distribution of the number of heads, now this is what they want you to model the question. All right, they just want you to bring out like a model. That's the meaning of what is the distribution. So whatever model you bring out, of course, if they can go on to tell you to use that to answer different questions, but they need you to model this question. So first of all, you notice that they did not tell you that this is a Bernoulli or a Poisson or a binomial. They just told you toss a fair coin once. They now say, okay, what's the distribution of the number of heads? So number one, the first thing you need to know is, okay, first of all, this is a Bernoulli. So this is a Bernoulli distribution. What's the PMF? You get the PMF out. Of course, if you don't know the PMF, there's no way you want to write this out. Now, the next thing they expect you to do now is, they say, what's the distribution of the number of heads? Number of heads. Look at the specification there. Distribution of the number of heads. They didn't ask you to just, they didn't say what's the distribution of the experiment. They say what's the distribution of the number of heads. So they're not asking you to just write the PMF of a Bernoulli distribution. They want you to tell them what division of the number of heads is. So the first question you have to ask yourself, which is the only thing you can do here, what's the probability of getting head in tossing a fair coin once? Guys, what's the probability of getting head? Because in this case now, number of heads will represent success. That means you getting head will be the success here. All right. Now, because you need to understand how to thank you guys. I can see your answers, very correct. When they say what's the division of the number of heads here, you read from the question to know exactly what's going to be success and what's going to be failure. Getting heads here is success. That means your P will be probability of getting head, which all of you know. That's why you had to have attended the probability class before now. The probability of success when you toss a coin up, probability of getting head is going to be 1 over 2. All right. So, guys, you have gotten the probability of getting a head as 1 over 2. So, the distribution of the number of heads, which you're going to be getting from PMF, will be probability of course, you know this already, probability of x equals to x will be equals to, of course, you know that's how we're going to write the PMF. Now, P here is 1 over 2, so you'll be writing 1 over 2 raised to the power of, you don't know anything, you're not asked to find anything here, you're just going to so if you can understand what's going on here, you can see that this is the distribution of the number of heads. 1 minus half, of course, that's still half. 1 minus x. So this is the distribution of the number of heads. All right. This is the distribution of the number of heads. So this is the question. This is the answer to your question. What's the distribution of the number of heads? This is the answer. All right. So simple. Now, let me give you another one and let's see how you fare with that. Guys, can you still hear me? So you're going to do this yourself. Let me see how attentive you guys are. Hope you guys are following. Hope it's making sense. The next question is this approximately 1 in 200 American adults, approximately 1 in 200 American adults are lawyers. One American adult is randomly selected. So the question is similar to what we had in the last one. So can anybody give me the answer to this in like 1 minute, because it's very similar to what we just did. So the question said approximately 1 in 200 American adults are lawyers. 1 American adult is randomly selected. What is the distribution of the number of lawyers? Guys, first of all, the first question I want to ask you, because I told you guys, nobody's going to be telling you, wow, it looks somebody is near, probably near. I'm not sure if the person is correct yet. I'm going to talk about that in a second or in some few minutes. Approximately 1 in 200 American adults are lawyers. 1 American adult is randomly selected. What's the distribution of the number of lawyers? First of all, guys, what distribution are we talking about here? What distribution are we talking about? What distribution is this? Is it a Poisson? Is it a binomial? Is it Bernoulli? Is it geometry? Is it a beta distribution? Is it gamma? What distribution are we talking about here? If you look carefully at this, you would see your answer in the question. And this is it. 1 American adult is randomly selected. You can see right here that we are only having 1 trial. 1 American adult, 1, not 2, not 3. So your trial year is just one. So one American adult is randomly selected. Now, the next question I'm going to ask you guys. So you already know this is a Bernoulli distribution. Good. So if there is a Bernoulli distribution, you know obviously that your PMF is going to be P raised to power X. This is, of course, something I've explained earlier. This is your PMF. Now, but the question said, what's the distribution of the number of lawyers? So now, guys, what's going to be P in this question? What's going to be P? P represents the probability of success. Don't forget, P represents the probability of success. P represents the probability of success. So, what's the probability of success in this question? How do you get it? The last one we did, tossing a coin, you knew how because of our previous because of what we did previously. So when you toss a coin, probability of you getting a head is going to obviously be 1/2. But in this case now, what's the probability of success based on this question? And how do you get it? We're talking about number of lawyers. One American adult is randomly selected. What's the distribution of the number of lawyers? This number of lawyers now, what's the probability of getting a lawyer? P, success. What's the distribution of the number of lawyers? What's the probability of getting of having success in selecting a lawyer? Yeah, I'm seeing the answer there. Yeah, this is where your answer is going to come out from. The question said approximately 1 in 200 American adults are lawyers. 1 in 200. So the probability of selecting or choosing an American adult lawyer, this is where the answer is. 1 in 200. Don't forget, number of event space over number of sample space. So they said if this in a sample space of 200 American adults, the event space of you getting a lawyer is 1. So obviously you know that the probability of success there is what you will see as 1/200. This is NE. This is 200 is NS, because 1 in 200, the sample space, total number of possible outcomes in this case 200. Number of elements in the event space is 1, because they say 1 in 200. All right. Now, so obviously we have P as 1/200. That's where you get it. So your PMF now, for us to get the distribution of the number of lawyers, will be P, that's 1/200, raised to power X, then 1 minus 1/200, raised to power 1 minus X. We go on to solve this perfectly, and this will be 199/200 raised to power 1 minus X. All right. This is of course, if 1/200 represents the probability of success, then 1 minus 1/200 will represent the probability of failure. You already know that the probability of success plus probability of failure must give you 1. All right. Good. Now, guys, this one is for you. Take this question now and let's see how you're going to solve it. A 6-sided fair die is tossed. 6-sided fair die is tossed. With each element in the sample space having a probability of 1/6. Find the distribution, the mean, and variance of the value if the value 5 occurs. So a 6-sided fair die is tossed with each element. I'm not going to write that, but you can write that with each element in the sample space having a probability of 1/6. So the question is for you to find the distribution. Then you have to find the mean and the variance if the value 5 occurs. All right, so let me see what you guys are going to do with this. A 6-sided fair die is tossed with each element in a sample space having a, of course, you know that each element in the sample space for a die is having a probability of 1/6. Of course, you understand that. That means we're having probability of having 1/6, and so on and so forth. So you know the probability of having 5 is also 1/6. So the question says you should find the distribution, the mean, and the variance if the value 5 occurs. So the first one is for you to find the distribution. Now, I believe we can be a bit quicker because everybody here should know that the probability of success for the values 5 occurring is equals to 1/6. That's obvious. You know that. The PMF, generally, because we are only dealing with, we didn't toss this die multiple times. We just said a six-sided fair die is tossed. So if it's tossed, it's not tossed more than once. Of course, it's just tossed once. So of course we know we are dealing with a Bernoulli distribution with the PMF giving us p raised to power x, then 1 minus p raised to power 1 minus x. So in this case now you can see that this will be 1/6 raised to power x, 1 minus 1/6 raised to power 1 minus x. I have 1/6 raised to power x, 5/6 raised to power 1 minus x. This is the distribution if the value 5 occurs. Now the next question said you should find the mean. All right. I told you guys already that the mean of a Bernoulli distribution is given as what? P. So the mean, since this is a Bernoulli distribution, that means the mean will obviously be what? 1/6. That's simple, bar. And then the variance, I told you guys that the variance is given as P times Q. And you know that your Q obviously is 5/6. So your variance will be 1/5. Sorry, I said 1/5, 1/6 multiplied by 5/6. And that will be what? 5/36. Are you seeing that this is too simple, right? This is too simple. Too simple. This is, I told you guys, this is just everything. I want you guys to know that that's just everything. I will ask you some few questions. I would like to get your response just to conclude Bernoulli distribution. I want to ask a few questions. The first one, please type your answer quickly in the comment section. How many possible outcomes can there be for distribution? Option A, more than 1. Option B, more than 2. Option C, exactly 2. Option D, exactly 1. What's your answer? A, B, C, or D? How many possible outcomes can there be for a Bernoulli trial? A, more than 1. B, more than 2. C, exactly 2. D, exactly 1. How many possible outcomes can there be for a Bernoulli trial? A, more than 1. B, more than 2. C, exactly 2. D, exactly 1. I can see different options. Some people are saying D. So now, it's good I'm asking you guys this question because many of you are not getting the answer yet. The option said more than 1 as option A, more than 2, C, exactly 2, D, exactly 1. For a Bernoulli distribution, exactly 2 possible outcomes. It is not exactly 1. How many possible outcomes can there be for a Bernoulli trial? There is only one trial with 2 possible outcomes, success or failure. So the correct option is option C. Exactly 2 possible. In a Bernoulli trial, the probability of success is 0.3. In a Bernoulli trial, the probability of success is 0.3. What is the probability of failure? What is the probability of failure? Quickly, if you are here to give us a thumbs up, please do that quickly. Give this video a thumbs up quickly. In a Bernoulli trial, the probability of success is 0.3. What is the probability of failure? Of course, as I said already, if the probability of success is told to be 0.3, you know that probability of success plus probability of failure must be equals to 1. And if this is 0.3, that means the probability of failure will be 1 minus 0.3. That will be 0.7. All right? Good. The last question under Bernoulli I'll be asking is this. The probability of success in a Bernoulli trial is 0.3. The probability of success in a Bernoulli trial is 0.3. What is the variance? What is the variance? What is the variance? The probability of success is 0.3. What is the variance? Option A, 0.07. Sorry, 0.09. Option A, 0.09. Option B, 0.7. Option C, 0.3. Option D, 0.21. The probability of success in a Bernoulli trial is 0.3. What is the probability? Sorry, what is the variance? So you have 0.09, you have 0.7, you have 0.3, and you have 0.21. So if the probability of success is given as 0.3, that means probability of failure will be 1 minus 0.3, which is 0.7. And the variance for a Bernoulli distribution is given as P times Q. That will be 0.3 times 0.7. That will be 0.21. Right? Good. So we can move straight into binomial distribution. That is all about Bernoulli. You can see, I told you guys it's so simple. It's too simple. We are not doing 4 this night for that person writing. We are doing just 2 this night. Tomorrow we'll be dealing with Poisson and geometry. Very, very important aspect. Those Poisson and geometry, you must make sure you are very attentive. Now, binomial distribution. Again, it's a... Okay, somebody's asking for a recap. I'm going to recap while explaining binomial. Don't worry. I told you guys that we have discrete and we have continuous probability distribution probability functions. Now, for discrete, we always say probability distribution function. For continuous, we say probability density function. Now, under discrete, we have 4 different types. In this class, we want to measure more Bernoulli and binomial. I told you guys that the two are very similar, but there's just one thing. There's just one thing that differentiates the two of them. Bernoulli has 1 trial, whereas binomial has n trials. So under binomial, we're not concerned about any number of trials. It can be 10, it can be 20, all right? But Bernoulli, it's just 1 trial, which you can see in all the many examples we have done. 1 trial alone. Now, both of them, they always have just 2 possible outcomes, exactly 2 possible outcomes, and that's success or failure. The same thing goes for this. In all of these n trials, each of those trials, each of them, there's only 2 possible outcomes, success or failure. All right? In each of the n trials. So let's say, for instance, let's say we toss a coin up 10 times. The first trial, there's just 2 possible outcomes, success or failure. The second trial, success or failure. The same thing will go on up until the 10th trial. So that's the difference between binomial and Bernoulli. All right. Now, that being said, if I'm going to read it, let me just read this out for those of you that need to write. Binomial distribution is a discrete probability distribution of the number of success in a sequence of n independent yes or no experiment. Let me stress a bit on that. You see the use of the word independent there? The meaning of that is that these n trials that we're talking about. So guys, as I was saying, the use of the word independent there is very important because you must understand that each of these n trials, sometimes it could be 5, it could be 4, it could be 3, it could be 10, it could be whatever number n means. You need to know that they are dependent on each other. That means none of these trials depend on each other. Very, very important for you to note that. Now, I said this deal with repeated and independent trial of an experiment with two outcomes, either success or failure. All right, and we often represent success as 1 and failure as 0 in many cases, of course. But this is what I need you to focus on. Let's talk about the PMF. Let's talk about the PMF. I told you guys that in all of these distributions, we have their various PMFs. So what's the PMF for binomial? I told you already that it's very similar to Bernoulli. The difference is that in this case now we'll be having a number of trial, not just one. Of success and probability of failure, which is 1 minus p or q, raised to power number of failure, which I told you in this case will be n minus x. The reason why n minus x is because we don't have just one trial here, we have n trial. Now, but there is something that you must understand. To count the number of scenarios happening here, we must include n combination x. Let me just write it this way. You understand that this is a way of writing n combination x. And you must also specify the values for your x, because now we're talking about x now, we're not just dealing with one experiment. So your x, don't forget, in case, let me write this under, that your x represents the number of successes in n trials. Note that, please, you need to remember, there are some things that are key for you to never have issues with this topic. You need to understand what x represents so that you will not, so that you don't have any issue. You must really understand the number of what all these things represent. So x here represents the number of successes. Please, is anybody having a network issue there? Are you guys able to flow? Please, can you indicate if you are flowing with me? I want to know because I'm seeing some people talking about the network. Is it clear? Can you hear me? Capital X, because capital X is actually, the values you'll be giving is what we represent as small x. All right, capital X. So that means, what I mean is, if I write probability of x, that means the number of success here is equals to, I could write 2. So that's what small x is just representing the number it will take. So x here is what is the number of successes. So in this case, now if I write, if you will see where we're going to be applying this now. Let's say the question said, find the probability of getting a head 2 times. That means the number of success now we are saying is 2. This is the probability you'll be looking for. All right. Don't forget, guys, can you relate to when I was telling you in the beginning of random variable class, where I told you that what random variable is? I said it's a numerical representation for things you would have written, right? X equals to head, all those things. Instead of writing probability of head, now I can write probability of x equals to 2, meaning probability of having 2 heads. If you remember when I was explaining this, if I wanted to talk about you having uh, less than or equals to 3 head. I can write probability of x less than or equals to 3 head. So this, I told you, if you remember the introduction to numerical to random variable, I explained to you that one of the major use of random variables is because it gives us a way of expressing probabilities without having to be writing probability of head, probability of head, tail, all those things. You don't need to write that. As it helps us to make lots of calculation, which is one of the things you are seeing in this class. So x there represent the number of successes. You will see that very soon. You'll see us using to solve questions. Bernoulli is quite very simple. That's why you didn't have to solve too many questions. But in this case now, if you had 10 trial, I may say, let's say you are tossing a coin 10 times. I may say what's the probability of having a head 5 times. That's the number of success there will be 5. That means I'll be using probability of x equals to 5 in that case. That's what I'm going to be finding using this PMF. And you know how it's going to always produce the answer correctly. So look at the question we have here. I need to include what your x values can be. That means the responses to your number of successes. That x, small letter x now. Small letter x now will obviously be taking values from 0 because it's possible that the number of success was 0. Don't forget, this small letter x is representing the response for the capital letter x. Capital letter x represents the number of successes. So the number of successes could be 0. The number of successes, it could be 2. Now, but you don't know the number of trials. That's why we're going to just write up until n, depending on whatever trial you're dealing with. So if you are dealing with 20 trials, then your x could take, the meaning of x here is number of successes, don't forget. You could have 0 success. If you have 20 trials, you could have 0 successes. You could also have 20 successes. This is an experiment, a random experiment. You don't have any predefined something. You can toss a coin up 20 times and get a head 20 times. You could toss a coin up 20 times and get a head 0 times. So x will take values from 0. It must take value from 0 up until n, depending on the number of trials you are dealing with. All right. So this is the PMF for a binomial distribution. Very simple. It's very similar. It's very similar to that of Bernoulli. Please, are you still following? I'm seeing some people talking about loading, trying to show emojis for loading. Is it everywhere or just them? Is anybody flowing with me clearly? Can you indicate if you can really hear me? Okay, it's all right. So now you can notice that the values for x here are taking integer values, whole number. That's the reason why we call this a discrete probability distribution, because the values are countable. All right. Now we're going to go on now to start cracking lots of questions. Now you would see the main use of this distribution. It's a very, very important distribution. It helps you to solve questions easily. But don't forget, this formula, you must know it. Look at it. I told you this is probability of success raised to the power number of success, probability of failure raised to the power number of failure. And you're understanding the explanation to all this already. P plus Q must be equals to 1. This is probability of failure. Because if you had 20 trials now, if your number of success was 12, if 12 was your number of success, that means your number of failure will be 8. That will be 20 minus 12, 8. This is the general mathematical model that represents a binomial distribution. And what you have here, which is n combination x, n combination, because we have more than one trial. So this is what ensures that we put into consideration all the number of trials, n combination x. So that's very simple. All right. Now let me quickly talk about the mean and variance, which I've already said. I've already spoken on this already. The mean for a binomial distribution, the mean, mean can be represented as mu. That's, of course, I told you already, is NP. The variance, which we can represent as sigma square, is NPQ. Or someone could write it as N. Someone could decide to write it as NP1 minus P. You know the difference. You understand what's going on there. And of course, you know the standard deviation, which is just sigma. Standard deviation will be seen as the square root of NPQ, because square root of variance is always standard deviation. I believe everybody understand all these things. There's no big deal on all these ones. Let's now run to questions. A balanced six-sided die is rolled. A balanced six-sided is rolled 3 times. A balanced six-sided die is rolled 3 times, rather. So a balanced six-sided die is rolled 3 times. What's the probability if 5 comes up exactly twice? This is why you need this probability distribution. Look at a balanced six-sided die is rolled 3 times. What is the probability that a 5 comes up exactly twice? Now, is it, I hope, those of you talking about it being blue, I hope it's adjusted already. So now, I told you guys already, nobody will tell you this is a Bernoulli, a binomial, a Poisson. Nobody will say that. Look at, imagine we were not talking under binomial and you just saw this question. A balanced six-sided die is rolled 3 times. What's the probability a 5 comes up exactly twice? So the first thing that comes to your mind is that this question, what distribution does it follow? What distribution does it follow? That's the first question you want to ask yourself. Now, when you roll a die up 3 times, you obviously know this can never be a Bernoulli distribution, because Bernoulli only has to do with one trial. You're already having more than one trial here, so it can never be a Bernoulli. Now, you have 3 trials happening here. In these 3 trials, you're dealing with a die. You look at the experiment, a die. What's probability a 5 comes up exactly twice? In each of these trials, how many possible outcomes do you have? Of course, you can have a 5 or not a 5. That means you can have success or not success. So that means in each of these trials, we have 2 possible outcomes, success or failure. Now, when I look at all these things, I already know that X, the random variable here, X, random variable X, follows. I'm actually introducing this so that you guys, you need to understand that not all questions will be written in word problems. They could ask you a question using this. You already know that X in this case follows a binomial distribution. This is how I want you to be familiar with it. This is how you write X following a binomial distribution. Note this. You may see a question tomorrow that will just say, if X, or probably they will use Y. Don't be confused with the use of the word X all the time. X is just representing the random variable. It could be Y, it could be Z, it could be anything. Capital letter, mostly X, but if they use Y, don't be confused. It's still random variable. So if they say X follows a BER and they just write something. Let me give you an example of that. Let's say they just wrote X BER 0.3 and they say find the variance. And you're looking here, you're like, what's going on here? What's going on here? I don't understand. This is what's going on here. Guys, the meaning of this, when you see X follows a BER, that means they're saying a random variable X follows a Bernoulli distribution. And there's only one parameter in the syntax for Bernoulli. That's only P. Whereas for that of binomial, we have N and P. So if you see them write something like this, if they wrote 5, 0.1, and you're wondering, and they say find this something, and they ask you to find something, and you're wondering, sir, they didn't give me any value here. Please be very smart. What they told you here, the first thing you have here is representing your N. The second one is representing your P, not P. So you should understand that in this case, you already have your N and you have your P. I remember an exam that I was given some years back, probably 1 or 2 years back, I'm not sure, which probably 1 year or 2 years, I'm not sure. And the question came out very simple, very, very simple. It was something that has to do with this kind of syntax. And many students failed it because they forgot, all right? They forgot how to interpret when you have questions like this. So, because the one for Poisson now, I will get to that very soon, but let me just give you an instance of it. If you see for Poisson, you'll be seeing something like X follows a PO, it could be P or PO, and they write just one value there. That value is representing lambda. Of course, we are not talking about Poisson today, so you don't need to ask me what does lambda mean. But for Poisson, you will just write something like this, and they expect you to know that whatever is inside the parameter there is Poisson. Is the lambda. So please, you guys should be familiar with this. So back to the question we have here. When we say a balanced six-sided die is rolled 3 times, we obviously know that this is obviously a Poisson distribution, and this experiment follows a Poisson distribution. So we know that in this case, it's a sorry, I say Poisson, sorry, binomial, and the binomial has 3 trial, and of course, probability of success here. What's going to be probability of success here? Because what is probability? A 5. Probability of having a 5, you already know that already. We are not anybody that has been following this class know that when you are tossing a die up, probability of having a 5 success, that means probability of having success of having a 5 will be 1/6. You know that already. I don't think I need to stress so much on that, because when you toss a die up, probability of having a 5 is 1/6. And probability of not having a die, that means probability of failure will be 5/6, which will represent the other possibilities. It could be 1 or 2 or 3 or 4 or 6. If you do that, if you solve that in using probability, you'll be having 1/6 plus 1/6 in 5 places, and that'll be 5/6. All right. So when you have a question like this, you ask find probability that a 5 comes up exactly twice. Now, let me talk a little bit on this word exactly twice. That means they are telling you a particular number of success they want you to find the probability of. I told you guys that X represents the number of success. I told you that in the last when we were explaining the PMF of a binomial distribution. That means in this case, they're asking you to find a probability that X is exactly twice is equals to 2. That's what they're asking you to find in this question. What's the probability that a 5 comes up exactly twice? Exactly twice. There are many other questions that can come up. You can say, what's the probability that it comes up exactly 3 times? You can say, what's the probability that it comes up exactly once? There's no probability that it comes up at least 2 times, or at most 2. Those many questions are possibilities that you should be expecting. All right. Now, they actually find a probability that it comes up exactly twice. The next question now is, what's your PMF? You guys know your PMF, just for the sake of making sure you guys are very familiar with it. The PMF for a binomial distribution is going to be n combination x. You know this already, p raised to power x, and then 1 minus p raised to power n minus x. Don't forget your x will always range from 0 up until n. These things are very vital to always have to whenever you are stating your PMF. Always tell the examiner that you are very sure of what you are doing and you know what your value for x is. All right. Just for digression, for Bernoulli, the possibility of x is only 0 and 1, because the number of success is either 0, because you only have 1 trial. So in that case, you don't have x ranging from 0 to n, because you don't have n trial, you only have 1. So x can either be 0 or 1 under a Bernoulli distribution. Good. So let's move on now. Now that we have this model, this is the model. We already know what our this question follows. It follows a binomial distribution. So what we need to do next is to fix in our values. We want to find probability of x equals to 2 now. That means our x now is 2. So we know exactly what we are looking for. n combination x, n here was what? N is 3. Number of trial 3 times. That will be 3 combination 2. And probability of success 1 over 6. 1 over 6 raised to power 2. Then 1 minus 1 over 6 raised to power what? 3, which is n. Your n is 3. Minus what was your x? Your x in this case is 2. All right. This is a binomial distribution. So 3 combination 2. When you press all this in your calculator, what do you get? You should get a value of 0.0694. Of course, you know this is in 4dp. You see exactly what's going on here. This is the power of binomial distribution. You get values quickly without wasting time. Right? So all you need to do is, let me recap a little bit so that you guys can understand, because I know this is your first time. So it's not wrong if you are still trying to move along, but it's time for you to start graphing everything much perfectly. So you understand that when you see a question like this, you understand that this is obviously a binomial. And why is because it has one trial. If it was one trial, it's going to be a Bernoulli. It can never be a binomial with one trial. Never. It's a Bernoulli if it's one trial, but it's binomial when it's more than one trial. All right. Now, what probability a 5 comes up exactly twice? Each of these trial, there are 2 possible outcomes: success or failure. That means you either had a 5 or you don't have a 5. The question now is probability of you having a 5 exactly twice. You guys are going to find probability of having a 5 come up exactly once. That's the question I want you to solve. All right. What's probability of having a 5 exactly once? You guys that understand what I'm saying can keep solving already. But to solve that of exactly twice, that means they are telling you that the probability of, don't forget, your x represents the number of success. That was why I was stressing on what x represents, so you guys are not confused. When you have this your formula, this your PMF, your x here represents the number of success. All right. So when you say x under binomial, you're saying the number of success is equals to whatever the question was asking. In this case, the question said you should find that the number of success was exactly twice. That means equals to 2. But generally, this is the PMF of a binomial distribution. So you want to find exactly the 5 coming up exactly twice. You're rolling a coin, a die rather, 3 times. So the number of trial there is 3. X, of course, is 2. Probability of success is 1 over 6. Probability of failure will be 5 over 6. That's 1 minus 1 over 6. Then you put this all there. Put it in your question and what you're going to get. Now, guys, I want you guys, everybody, I want to see your answer now. What's the probability a 5 comes up exactly once? What's your answer? What's your answer? What's the probability a 5 comes up exactly once? Okay, so if you're asked to find the probability of that happening, what you need to just know is that in that case, your number of success is 1, because exactly once means you have to find probability of x equals to 1. So you go on now to fix this into your formula. That will be, of course, you're still dealing with the 3 trials. All right, that will be 3 combination 1. In this case now, because x is 1, then your number of success, your probability of success is 1 over 6 raised to the power, number of success in this case was 1, and then 5 over 6 raised to the power 3 minus 1, which will be 2. So if you put this all in your calculator, what do you get? You put all this in your calculator. This is 25 over 36. 25 over 36, that's 25 over 36 times. Then if you do all those, what do you get as your final answer? 25 over 72. So that's how you solve questions like this. Now, just to ensure we can get the best out of this question, if you are asked, I want us to use this question to tackle a whole lot of things so that you guys can be very versatile in this topic. What if I ask you that what's probability of having a 5 comes up at least once? They are going to do at least once. These are the two questions I want us to answer. Okay, let me say at least twice. The first one, at least twice. And the second one, at most twice. Let's do this. Let's try and solve this. This will really give you a whole lot of advantage in solving all these questions. So we have this same question now, but this same experiment, but two different questions are coming up now. You are asked to find the probability that a 5 comes up at least twice, at least 2 times, obviously, and at most times. Now, guys, when you see questions like this, you must be very alert to the meaning of the word at least. The word at least means the least you can have is 2. The least you can have is 2. So this question is not saying exactly 2 now, as opposed to what we just did. That's different. This is different. In solving this question number 1, you are interested in you having it happening at least twice. That means the least must be 2 times that you must see a 5. So you can see a 5 2 times, or you can see it 3 times. Look at it. At least twice mean if you have a 5 show up when you toss the die 2 times, at least twice, because at least you have seen it twice. Now, but it's not just twice. You can also see it 3 times. You are still fine if you saw it 3 times. If you saw it 3 times, you are still fine because it said at least. Now, look at the reason why we are having only 3 times, because the maximum trial is 3 times. So if you hold a die and toss it up 3 times, you cannot have a 5 show up 4 times because it's not possible. You only toss the die up 3 times. So you could never have it show up. You could never have it show up 4 times. That's why we are only having it the maximum is 3 times. All right? You should understand what that means. Now, the second one that said at most twice. The meaning of at most twice means the highest must be 2 times. At most twice. That means the highest. In this case now of at most twice, you must not see anything above 2. So in this time, we are featuring 2 times as the highest, or we are still okay if it was 1 time. 1 time, not times. So who cares? This is mathematics. Man. So 1 time, but this is where many people used to make mistakes. All right. They only do 1 time or 2 times when dealing with at most twice, but that's not true. You should always include 0 time also. 0 time is also a possibility. Don't stop at just 1 time. We said at most twice. That means at most, the highest must be 2. But if it's 1, we are okay. If it's 0 time, it's still at most. That means we are still under the word at most. The word at most said the highest must be 2. So 2, 1, 0 is still under at most twice. But for that of at least twice, the least must be 2 times. So you can have 2, you can have 3. Now, how do you solve this when you have a question like, how do you solve this question? Well, if you want to solve questions like this, let me try and solve for that of number 1. The meaning of this is that you will say, I'm finding probability of course, a 5, because in this case, the experiment is mirroring a 5. But in another experiment, it may be different, so you don't have to be rigid. But the success now of using a 5, if it's exactly 2 times you saw a 5, you are okay. Or if it was 3 times, you are fine. Use that word or, and you know the word or in mathematics, in probability, is plus. So what you will do in solving this question of at least twice would be for you to go and use, let me try and bring it out here. For this experiment, you'll be having 3 combination 2, P, which is 1 over 6, raised to power 2, then 5 over 6 raised to power 3 minus 2. That's for this side. Then plus, this plus is what the or is replicating. That of 3, which will be 3 combination 3, your x here is 3. All right? Then you have 1 over 6 raised to power, in this case 3, then 5 over 6 raised to power 3 minus 3, which will just be 0. So all this return to 1 because anything raised to power 0 is 1. Now, for you to solve this question of at least twice, this is what you have to solve. You have to go and solve this and add it with this, and that's your answer. For that of at most twice, what you have to do is that you must solve for when, of course, when the number of 5s that show up was equals to 0, or when it was equals to 1, or when it was equals to 2. This is what you will be solving for you to get your answer correctly. Now, of course, you know what's going to happen here. This is going to be 3 combination 0, 1 over 6 raised to power 0, then 5 over 6 raised to power 3 minus 0, plus, in this case, just replicate this. Let me just put this way. Just replicate this here. No, sorry, not replicating that. Sorry, I thought this was 2. So you're going to be having 3 combination 1 over 6 raised to power 1, 5 over 6 raised to power 3 minus 1. Then you have plus 3 combination 2, 1 over 6 raised to power 2, 5 over 6 raised to power 3 minus 2. So for you to solve at most twice, this is what you have to do. You have to solve for when x was 0, when x was 1, and when x was 2. So this is really great. I want you guys to be so exposed that you are not having any issue in solving these questions. I'm going to give you guys this question, and this is going to be the last question for this night because I want you guys to go and get your mind settled around this. Then I will still expose you to more questions on binomial, but for the sake of, I don't want you guys to get too, I want you guys to have your time to study this. So this video will be available latest by 11 a.m. tomorrow. So don't forget, we'll be having Poisson tomorrow, but then we would have the time to solve more questions on binomial distribution. So we have multiple questions, different type of questions that could come up on this, and I want you guys to be very alert. I'm trying to narrow down the questions for this night a certain perspective, and the reason is because I don't want it to blow up in this. So I'm trying to be very careful. I don't want to bring questions that would make you guys feel this is so difficult, and the only reason why you may be feeling that way is because you have not yet gotten your head around the whole concept. So if you study this, and you get conversant with it, gladly I would love to start exposing you to the other types of questions. Now, they are all going to be the same thing. The only difference would be that you know something about word problems in mathematics. There's a way they could twist a question, something you could understand quite very easily, but they would write it in such a way that you would have to be very, very smart to bring out the answers, to bring out the different variables there. That's the reason why I just want to take it bit by bit. So once you are very good with these ones we have done, then I will give you other questions where it comes with a little bit of word problem. Of course, very simple once you're able to bring out the word problem. Now look at this question. A six-sided die is rolled 12 times. What is the probability of getting a 4 5 times? And then let me add to this. Probability of getting a 4 at least 3 times and at most 3 times. So these are the five these are the 3 different questions I want you to solve quickly. Let me see how you guys fare with this. So guys, start to move with this, and let me see how you do this. Let me see your approach to this. So a six-sided die is rolled 12 times. Nobody is telling you what kind of distribution this is following. You have to figure out that yourself. So first of all, this could never be a Bernoulli distribution because I can see that this thing is happening 12 times. Bernoulli will always happen just once. So because it's happening 12 times, I already know that this will be a binomial. So I know in this case that my random variable x is following a binomial distribution. Of course, my n is 12, and I'm tossing a die up. I'm rolling a die. Probability of getting a 4 5 times. So I know that when I roll a die, probability of getting a 4, probability of getting a 4, the success P will be 1/6. I believe everybody should know this already. We have done this in our previous classes in under probability. So n here is obviously 12 and P is 1/6. So the question said, what was the probability of getting a 4 5 times? Now, a 4 5 times, this 5 times being recorded here is indicative of the number of successes. That means you are saying now that X, let me write it this way. The question is trying to say, what is the probability of getting a 4 5 times? The probability of getting a 4, the number of success here is 5. That's the question. So, and since this follows a binomial distribution, I obviously know that this will be 12 combination. In this case now, of course, you know I believe you guys should, okay, let me just, the PMF of a binomial, you guys should know it already, n combination x, p raised to power x, then q raised to power n minus x. So in this case, our x is 5, that will be 12 combination 5. Our probability of success is 1/6. 1/6 raised to power, our x is 5. X is 5. So don't forget, small letter x is just the value attached to capital letter X. So you should understand that it represents the number of success in this case. So, and then we'll be having 5/6 raised to the power of 12 minus 5. All right. So if you go on and press this on your calculator and solve this, you should get the value of 0.028425. All right. So you can see how many of you got this answer? You know, you have done this. How many of you got this answer? Okay. I can see different answers there. All right. So can you guys respond to getting this answer? How many of you was able to get this answer for probability of getting a 4 5 times? All right. Just to give you as a tip, this is going to be your take-home assignment. Of course, your exercise. For you to get at least 3 times, you know, obviously they are dealing with at least 3 times. At least. The least you must have there must be 3. So, and you have 12 experiments. At least 3 times is going to be really, really big. So those of you that you have started doing it, you have noticed at least 3 times means you'll be having 3. Least it can be 3. You'll be having 4. You'll be having 5. You'll be having 6. Having 7, up until 12. At most 3. At most 3 will be 3, 2, 1, and 0. All right. Because at most 3. So now, just to give you, please guys, listen to this, and you would really understand what I want. I want to teach you something smart here. If you're given these 2 questions, or if you're giving this question at least 3 times, time, and you are not very you don't know how to do it this way, you will go on to say you want to find probability of when x was 3, when x was 4. Of course, you have to be adding all of them to 5, to 6, to 7, to 8, to 9, to 10, to 11, to 12. That's a whole lot. A simple way of answering this to question number B, instead of doing all this, would be for you to go on to find the probability of at most 2. You know, when you go on, I'm still trying to find question number B. If you find at most 2, that means you'll be finding for probability of 2, probability of 1, probability of 0. All right. Now, you can see that if I now go on to say 1 minus, it will be giving me this answer, because you understand complementary event already. Complementary event, if the event of at most 2 will be the complementary event of at least 3. I don't know if it makes sense to you guys. At most 2, that's 0, 1, and 2. At most 2 will be 0, 1, and 2. The whole experiment, the whole possibility is 12. So you can see that at most 2, 0, 1, 2 will be the complement of at least 3. So if you have to find at least 3 for a long experiment like this, instead of you to go on to be finding for 3 to 12, you can just go on to find for at most 3 or at most 2, not at most 3, at most 2. At most 3 will be 0, 1, 2, 3, which will not be the complementary of this one, because 3 is included in both. But at most 2 will be 0, 1, 2. So if you find at most 2, you guys should confirm this when you are, of course, in your practice, when you're on your own, in your study moment. Do for at most 2. Do 1 minus at most 2. You should get the same answer you got if you did all this before. So this is what I taught you to just expose you guys to, so you are not very always disturbed in an exam hall with questions like this. So there's so much to learn, and this is where we're going to be stopping the class for today. You guys have really tried, and can you give me your feedback quickly? What's your take on this? Are you very I'm sure some of you are still trying to get your head around it, but some of you have already gotten your head around it. So what's your general feedback? How do you feel about it? Simple, right? Very simple. It's a very interesting topic, and there are many more questions that you guys can answer. So by 11 a.m. latest tomorrow, this video will be available, so you guys can have your time to understand it. The key to understanding this topic is make sure that every variable, every element, especially when I was introducing it, make sure you understood everything. Understand that number one, this is a discrete probability distribution, so you know that your values here will be in integers, whole numbers, nothing like decimal here. Number two, know that you must know what each of these things have, their features. So, and understand what each of the features represent. Understand that probability of success is P, probability of failure is Q, or 1 minus P. N represent number of trial. X is the number of success. And I told you that this monitor X is just more like, if X is the number of success, if you say X was 1, in that case, your small letter X was 1. So your small letter X can take value between 0 and N. So understand how all those things are. Look at all the examples solved. It's quite very simple. And once you do that, you cannot go wrong. I can really assure you. So guys, thank you very much for your time here. And I wish you all the best. I sincerely wish you all the best. All this, your efforts will not be in vain. You're going to really succeed. You're going to smash it greatly. A star is the goal. And you guys can really do it. So keep it up. Same time tomorrow. And horizontal distribution, geometry distribution, we'll see how we go from there. Thank you guys. Take care of yourself. Bye-bye.